Chapter 2 review. We have learned a lot of new ways to multiply so far this chapter, so we're going to review in the form of word problems. Please make sure you're working these out, and then when I work them out after you go ahead and check your work, please make sure you're checking your work along with my work. So I'm going to give you a chance to work each of these problems out on your own, and then I'm going to go ahead and work them out. Here we go. The first problem says, Graydon scored 8 points playing basketball. Cody scored 4 times as many points as Graydon. How many points did Cody score? Go ahead and solve this problem now. For this problem, we can do one of two things. We can, 1, just set up an equation, or 2, draw a model. So let's go ahead and take a look. If we were going to draw a model, what that would look like. We would have Graydon and we would have Cody. And Graydon scored 8 points and Cody scored 4 times as many points. So Cody would get 4 boxes and Graydon would get 1, and inside of Graydon's box would be an 8 because we know that Graydon scored 8 points. I don't have a total for this, I just have how many one person scored. So I already know how many Graydon scored. I'm going to go ahead and put 8s in all of Cody's boxes because he scored 4 times as many points as Graydon. And because I'm looking for how many Cody scored, I can circle Cody. And to find how many points Cody scored, I would multiply 8 times 4, which would give me a total of 32. Now for this problem, I can also go back into my problem and cross some things out, and that would help me create an equation. So Cody scored 4 times as many points as Graydon. I can cross out my times as many as and put a multiplication sign there, and I can put my G there for Graydon. So Cody is equal to 4 times Graydon. Now I know that Graydon scored 8 points. It tells me in my problem first thing. So I'm going to go ahead and replace my G with 8. And this is the same equation I solved down here at the bottom. Cody's score is equal to 4 times 8. So when I go ahead and solve that, Cody is equal to 32 points. And that's how we solve this problem. I can use a model, or I can just write an equation based off of the words. Okay, here's your next problem. Haley and Emma collected shells. Haley collected 6 times as many shells as Emma. Together they collected 42 shells. How many shells did Haley collect? Go ahead and solve this problem. For this problem, you are going to want to draw a model. So Haley and Emma are my 2 people, and Haley collected 6 times as many shells as Emma. So Haley gets 6 boxes and Emma just gets 1. Now it says together they collected 42 shells, so that's my total. And I want to know how many Haley collected. So I'm going to go ahead and I'm going to circle Haley. That's what I'm going to be looking for. Now to solve this problem, I'm going to first have to solve for my variable, or what goes in each of my boxes. When I count all of my boxes, I have a total of 7. So 7 times n is going to equal my 42. When I think about my multiplication facts, n is equal to 6. And then I'd put 6 in all of my boxes. So if I want to know how many shells Haley collected, I would count the number of boxes Haley had, which is 6, and I would multiply that by my value of my variable, which is 6. So Haley's number of shells is going to be equal to 6 times 6. 6 times 6 is equal to 36. So Haley collected 36 shells. And again, for this problem, I was given a total. It says together here. That's how many they collected. So this is the type of model that I can use when I have my total. I'm solving for my variable of n. I'm replacing it in my model, and then I'm circling what I'm solving for. So in this case, I was solving for Haley. Let's take a look at our next problem. This problem says Sahar and Faith baked cookies for the school bake sale. Together they baked 63 cookies. Faith baked 6 times as many cookies as Sahar. How many more cookies did Faith bake than Sahar? Go ahead and solve this problem. I am going to draw a model for this problem. So I have Sahar and Faith. My problem tells me that together they baked 63 cookies. So that's going to be my bracket of 63. That's what they did together. Faith baked 6 times as many cookies as Sahar. So Faith is going to get 6 boxes, while Sahar gets 1 box. I want to know how many more. So my first thing I'm going to do is I'm going to go ahead and solve for my variable of n. I'm going to count the total number of boxes that I have. And when I do that, I get 7. So 7 times n is equal to 63. My variable is equal to 9. So I'm going to replace that in all of my boxes. Now when I see how many more, that's going to tell me that I'm going to need to subtract. The first thing I'm going to need to do is figure out how many cookies each girl baked, and then I'm going to subtract their total. So to figure out how many cookies Faith baked, I would count the number of 9 she had, which is 6. So Faith is going to be equal to 6 times 9, which is 54. Sahar just has 1 9, so Sahar's total is equal to 9. And I would subtract these two pieces to find how many more. 54 minus 9 is equal to 45. So Faith baked 45 more cookies. Now when I have how many more and I have a model, there's also a little trick that I can do to solve this instead of having to solve for both Faith and Sahar. My model here shows me some overlap. Right here, I see that these two 9s are overlapping. So I can cross them out, and now all I have left is this last piece, which is 1, 2, 3, 4, 5 9s. 9 times 5 is equal to 45. This is another way for me to solve my how many more problem. By doing this, I am already subtracting Sahar's and Faith's. I'm counting those out, and all I have left is what their difference is, their how many more. This is another little trick for when I'm solving how many more. Otherwise, I have to find how many Faith baked, how many Sahar baked, and then subtract. Okay, take a look at this next problem. The Beach Shack rents about 3,000 beach chairs per month. How many beach chairs does the Beach Shack rent in 5 months? Solve this problem. Okay, so I have 3,000 beach chairs per month, and I want to know how many in 5 months. So this is going to be a pretty simple multiplication problem for me. Now the biggest thing I don't want you to forget about is those zeros. So we can cross them out here as long as we add them into our product. Now all we have to worry about is 3 times 5, which gives me 15 as a product. So 3,000 times 5 is 15,000. So how many beach chairs does the Beach Shack rent? 15,000 beach chairs. That's how many beach chairs they collect or they rent out. Okay, that problem was super simple. We're just multiplying by those numbers of tens, hundreds, and thousands. Here's our next problem. Paul's Beach Rentals rents jet skis. They rented 400 jet skis each month during the months of May through July and 300 jet skis each month during the months of August through October. How many jet skis were rented in all 6 months? Go ahead and solve this problem. All right, so they rented 400 beach chairs jet skis in each month during the months of May through July. So I'm going to want to list those months to figure out how many months that is. I have May, June, and July. And each of those months, they rent 400 jet skis. I'm going to write this out as a visual model of what I'm doing. My next thing I'm going to look at is my next months. It says, and 300 jet skis in each month during the months of August through October. So I'm going to write those down. I have August, September, and October. And 300 for each of those months. The last part of my question says how many jet skis were rented in all 6 months. I want to make sure I have 6 months worth. 1, 2, 3, 4, 5, 6. So I do. That's just a good way for me to check, make sure I'm solving my problem correctly. Now I need to figure out, well, what is my total number of rentals for those 6 months? So over here, for the first 3 months, I can do 400 times 3. Or I could add 400 3 times. This next section over here, I can do 300 times 3 or 300, add that 3 times. I'm going to do some multiplication instead of addition. So when I solve 400 times 3, I can cross my zeros out, place them here. 4 times 3 is 12, so that gives me a product of 1,200. Over here, I cross my 2 zeros out, put them in my product, and 3 times 3 is 9. Now, if I want to know how many were rented in all 6 months, I need to add those two products. So 1,200 plus 900. And when I add those two products, I get 2,100 jet skis were rented. So that is my final answer. 2,100 jet skis. I found that by listing my months, finding how many for those 3-month periods, and then adding my two products. Okay, let's take a look at our next problem. The Thomas family drove to Orlando. It took them 4 hours traveling at 73 miles per hour to make it to Orlando. About how many miles did they travel? Go ahead and solve this problem. Now I want us to pay close attention to the key word here, which is about. I don't want an actual product, I want an estimate. So it took them 4 hours at traveling 73 miles per hour. If I were to write out this problem, it would be 4 times 73. However, again, this word about sticks out, and it wants me to estimate my product. So that's what I'm going to do. I'm going to multiply 4 times, and then I need to round this number. I look at my greatest place value, which is a 7. That's in my tens place. Its neighbor in my ones place is a 3. That 3 is not going to add one more, so I'm just going to ignore it. So 73 gets rounded down to 70. Now I'm going to find my estimate. When I multiply this, I'm going to cross out that 0. 4 times 7 is 28. So it says about how many miles did they travel? They traveled about 280 miles to Orlando. Okay, so that was going through, and when I see that word about, it wants me to find an estimate. Our next problem, the gift shop ordered 4 boxes of new toys. Each box holds 1,270 toys. How many toys does the gift shop order? Solve this problem now using any method you would like. Now, when you're working out these problems and you identify that you're doing some multiplication, so here I'm going to be multiplying 4 times 1,270, it's important that you think about multiplication in terms of all the steps. So there are a lot of steps here for multiplication. There are a lot of opportunities for you to make mistakes. What I recommend that you do on your quizzes and on your tests when you're multiplying, especially when you're doing large numbers, is work the problems out 2 different ways. That way, if you make a mistake in one of the methods, you're able to identify, oh, I need to take a close look and make sure my answers are correct. So I'm going to go ahead and work this problem out 2 ways. I'm going to use the area model, and then I'm going to use partial products to work this out. So over here I have the area model. I'm going to multiply 4 times 1,000 and I get 4,000. 4 times 200 gives me 800, and 4 times 70 gives me 280. I would go ahead and add, I'm going to add 2 numbers at a time. Here I would get 1,080, and then I'm going to add that to 4,000. So my final product would be 5,080. I'm going to go ahead and do the same thing over here for my partial products. I'm going to multiply each piece times 4. So I get 4,000. Here I get 800, and here I get 280, and I'm going to add down because I've lined up my place values. That's the important part when you're doing partial products, is you're lining up your place values, and I get 5,080. By working these problems out 2 different ways, I'm able to make sure that I'm working my problem out correctly. I have a lot more opportunity to catch any mistakes that I make. So, how many toys did the gift shop order? They ordered 5,080 toys. Here's our next problem. It says a small tree has 8 branches. Each branch has 375 leaves. How many leaves are on the whole tree? Solve this problem now. So this is a pretty simple multiplication problem. I have 8 branches and each branch has 375 leaves, so I'm going to be multiplying. I'm going to go ahead and I'm going to use the area model, and then I'm going to multiply with regrouping and make sure I get the same answer both times. When I multiply with regrouping, 8 times 3 is 24. I add 2 zeros. Don't forget about your zeros. 8 times 7 is 56. I add 1 zero in. 8 times 5 is 40. When I add these 2 pieces, I get 600 plus 2,400. When I add these all together, I get 3,000 over here. I'm going to take a look at my next option to multiply, and I'm going to multiply with regrouping. 5 times 8 is 40. I put my 0, carry my 4. 7 times 8 is 56, plus 4 more is 60. And 8 times 3 is 24, plus 6 more is 30. I get the same answer. So my tree has 3,000 leaves. But again, notice multiplying using 2 different methods helps not only make sure that I get the right answer, but then if I did make a mistake, I would catch it a lot easier this way. All right, next problem. A citrus farm has 7 rows of citrus trees with 37 trees in each row. 19 of the trees in each row were orange trees. How many trees are not orange trees? Go ahead and solve this problem. A model might do you some real good if we're solving this problem. Okay, so here I drew a model. And it shows my 7 rows of citrus trees with 37 trees in each row. Now I'm going to show my orange trees. So orange trees are 19 of the trees in each row are orange trees. So I'm going to split my rectangle here, and this piece is going to be 19 in each of my 7 rows. So there's 7. If I had 7 even rows, I would have 19 trees in each of those rows. Now, I want to know what are not orange trees. So I want to know what this side of my citrus farm looks like. I don't want to know how many orange trees I have. I want to know how many are not orange trees. I could solve this problem a few different ways. One of the methods to solve this problem would be to find the total number of trees. To do that, I would be multiplying 7 times 37. I could then find, well, how many orange trees do I have by multiplying 7 times 19. And then I could go and subtract my total minus my orange trees, and that would give me my not orange. Or I could solve it another way. I could start with some subtraction. I could take my orange trees per row and subtract them from my total per row. So I could do 37 minus 19. That would give me the trees in each row that are not orange trees. And then I could multiply that times 7. So because 37 minus 9 gives me 18, I could then also do 18 times 7, and that would give me my not orange trees, or my other type of citrus trees. You can decide which of these 2 models you wanted to use. Let's go ahead and solve both to make sure we get the same answer. So here I have the 3 problems I'm going to solve. 7 times 7 is 49. I put my 9, carry my 4. 7 times 3 is 21, plus 4 more gives me 25. That would be my total number of trees. To solve for my orange trees, 7 times 9 is 63. I put my 3 and carry my 6. 7 times 1 is 7, plus 6 more is 13. Those are my orange trees. And I would subtract these 2 to find my not orange. So what I'm going to do is I'm going to write my 133 underneath so that I can subtract nicely and make sure I get the answer I'm looking for. So right now I have an answer of 126 not orange trees. I'm going to go ahead and multiply using my other method and make sure I get the same answer. 7 times 8 is 56. I put my 6 and carry my 5. 7 times 1 is 7, plus 5 is 12. So here I get not orange of 126. And doing my multiplication to find my total orange and subtract, I also get 126. So my answer of how many trees are not orange trees, 126 trees. Okay, we have 3 more problems to solve. Here's our next one. To get ready for Halloween, Lucy bought 5 bags filled with 123 pieces of Reese's in each bag. She also bought 7 bags filled with 87 pieces of Snickers in each bag. How many pieces of candy did she buy? To set up this problem, I'm going to have to find how many pieces of Reese's and how many pieces of Snickers. So I'm going to start with Reese's. I have 123 times 5 bags. And then for Snickers, I have 7 bags of 87, so 7 times 87. And here in my problem, it tells me I want to know how many pieces of candy did she buy. So I want to know, is Reese's candy? Yeah. Or Snickers candy? Yeah. So I'm going to be adding these two to find the total number of candy that she bought. I can set up my equation like this. I need to make sure I'm following order of operations, so I'm going to have to solve these two multiplication pieces before I add. Let's go ahead and do that. I'm going to use, let's use expanded form to solve these. My first step in expanded form is to expand my numbers. My next step is to distribute my single number into my parentheses. So I have 5 times 100 plus 5 times 20 plus 5 times 3 plus 7 times 80 plus 7 times 7. Now I'm going to solve for each of my partial products. 500 plus 100 plus 15 plus 560 plus 49, and now all I have to do is add all of these partial products together to get my total number of pieces of candy. So I have 615 pieces of Reese's and 609 pieces of Snickers, and my last step is to add my two pieces together. And when I do that, I get 1,224 pieces of candy. So that would be my final answer. Again, lots of work. We solve for Reese's, solve for Snickers, and then I make sure I answer my question, which is how many pieces of candy. So I have to add these two pieces together. Here's our next problem. Monica collects coins. She collects 6 rolls of quarters with 10 quarters in each roll. She also collects 9 rolls of pennies with 25 pennies in each roll. She then lost 8 pennies. How many coins does she have? Go ahead and set up your equation and then solve for how many coins does Monica have. So she has 6 rolls of quarters with 10 quarters in each roll, so 6 times 10. She also collects 9 rolls of pennies with 25 pennies in each roll. She lost 8. So we have to subtract that 8. And because I want to know how many coins she has, well, pennies and quarters are coins, so I would be adding these two pieces together. All right, my first step is going to be to multiply. That's what my order of operations, or PEMDAS, tells me. I don't have any parentheses, I don't have any exponents, so I need to look for multiplication and division. So I see some multiplication. I'm going to multiply 60 plus, and then I need to multiply 9 times 25. I know that 4 times 25 is 100. 8 times 25 is 200. 9 times 25 would be 25 more than 200, so 225. And then I'm going to subtract my 8. I'm going to go ahead and add these two pieces together first, and I would get 285, and then subtract 8 from there. So when I go ahead and subtract my 8, I would want to make sure that I write my problem off to the side to make sure I'm subtracting correctly and I'm regrouping when I'm subtracting. And I would get 277 coins. That's how many coins she has. Okay. Here's our last problem. I want to know which of the following is another way to represent 6 times 297. For this problem, what I really want to focus on is what's inside these parentheses. Whatever is inside these parentheses needs to go back and add up to what I started with. So I'm looking for a 6, and then I'm looking for a 297. When I look at this first piece for A, 6 times 200, well, that would give me 1,200. But then all I would have to do is add 97, and that would not make any sense. So A does not work. B, 300 minus 3. If I subtracted 300 minus 3, what would that give me? It would give me 297. That's always a good sign because that would allow me to go back to what I originally started with. I could cross this out and put 297 there. That would be a great sign. This says, okay, whatever is in my parentheses goes back to what I start with. That's what I'm looking for when I have a problem like this. My next piece shows me 300 plus 2. Well, 300 plus 2 is 302. So my problem is not 6 times 302. So this would not work because my problem is 6 times 297. And this last piece, well, 290 and 7 were expanded, but my order of operations would tell me that I would multiply this first and then add these two pieces, and that's not what I want. That's why those parentheses are really important. So my answer to this question is B, because 300 minus 3 ends up subtracting back up to what I start with of 297. Okay, that's our review for Chapter 2. If you have any questions or struggled with any lessons, go back and review those lessons. That'll do it for today. We'll start Chapter 3 soon.